Okay, number 9. The diagram on the right shows the function f(x) equals negative x power 3 minus 3x squared minus x plus 1 for the domain x is between negative 3 and 1 inclusive of both of the values. A, state whether the function f is discrete or continuous. Look at the graph here. This is called continuous. Why? Because we can draw the line. We draw the line connecting all the coordinates. Okay, so that is called continuous. So you might wonder how the graph, discrete graph is. For example, if we have graph like that, we just have certain value. For example, here, if x is negative 3, y is 4. Y is here, x is here. And then if for some reason we have another value, for example negative 2, we have another that value. We have, for example, other value here. And then maybe this is negative 1 will be here. Okay, 0, 0 and 1, 1. Okay, so for some reason, this graph, we cannot connect between the line. Okay, we cannot draw a line connecting between all the points. That is called a discrete. Okay, so when is it a discrete function? Okay, let's say we are talking about the number of people. Okay, of course, logically we cannot have negative. We have a number of people, so I just eliminate this line. In a house, one house have 2 people, another 2 houses have 4 people, 3 house has 7 people. Okay, so we connect them because we cannot have 1.5 people and then we have somebody here. Okay, so this is called discrete graph. Alright, and then A2, the range of values of the corresponding to the domain given. Okay, what is the domain? The domain is given as between negative 3 until 1. Negative 3 until 1. Okay, the domain is from here to there. Okay, so the codomain is from here until the top here. When x is negative 3, y is 4. When x is 1, y is negative 4. So we write the answer for that, for A2, will be fx between negative 4 and 4, from the lowest until the biggest. Okay, unfortunately, because here this less than or equals to, here is also less or equals to. And B, by applying the horizontal line test, determine whether f has an inverse function or not. So I will tell you the answer is no, because if you draw a horizontal line, we can get it intersect at different point. Okay, in order to determine whether a function has an inverse function or not, it is only for one-to-one function, one object and one image. Okay, that is the answer for B. Okay, number 10. Given that the function fx equals modulus of x and fx equals to x to the power of 4 are not one-to-one function. Okay, that is a statement. A, determine the suitable condition in the domain of F so that the new function become one-to-one function. Okay, before even I answer this question, why does it say not one-to-one? Okay, so because if you have fx equals modulus of x, try to replace x as -1. So f -1 become -1 equals 1, and replace x as 1 equals to modulus of 1 equals to 1. So you see there are two objects with the same image. So two objects with the same image means first -1 here, it goes to 1, and then 1 goes to 1 also. Okay, so this is many to one relation, so it is not a one-to-one function, therefore it does not have okay, it's not one-to-one. Okay, sorry. Okay, and then x4, fx equals to x4, fx equals x to power 4. Similarly, you can replace this -1. Let's say this is -1. Power 4, you get 1. f1, 1 power 4, you still get 1. Okay, this is many to one also. Therefore, okay, not one-to-one. Okay, determine the suitable condition in the domain so that the new function become one-to-one. Okay, so we have to say either, we can say determine a suitable condition. We can say for A, determine x is less than 0, or you can say x is larger than 0. Any of these are correct. So if x less than 0, so you just take -1 only, so it maps to 1. There is no 1 here. But if let's say you say x larger than 0, so fx, replace x as 1, you get 1 only without the -1. Okay, so okay, less or equals to 0, larger or equal to 0. Any one of these. Okay. And then from A, find the inverse function for each of the function. So with the condition here, they have, so it is now become a one-to-one function. So it has the inverse function. So the function become fx equals x. We say x, for example, take larger than 0, and fx equals x power 4, x larger than 0 also, larger or equals to. And find the inverse. So the inverse for this first one will be, you have to say because this one will maps to, from x will maps to y, so you say the inverse of y, inverse equals x. Okay, so the function is modulus of x equals to y. Okay, so if you move this, basically nothing to do. Okay, nothing, just that inverse of x is still modulus of x. But then the second one, x power of 4, similarly, x here, y with there, object and image. So inverse of y will maps to x. So say let x power 4 equals y. So x equals y to the power of 1 over 4. So since this is x, here is x, so you have to say inverse of x is x power of 1 over 4. Okay, done with question number 10.